What's up guys, it's Joe here. I make tech interview videos on YouTube. So in this video I'll be doing binary tree in-order traversal. So given a binary tree, return the in-order traversal of its node values. And you can see here's that binary tree and here's the in-order traversal for it. So the main thing about this problem is that it says that the recursive solution is trivial. Could you do it iteratively? So I'll go over the recursive solution. So essentially, like the basic structure of a in-order traversal is that if the root is equal to null, then we can just return. Then we want to, in-order traversal towards the left. Then we want to do some kind of operation here, like visiting the root node, or this could be like printing it or something here. And then DFS towards the right subtree. So this is the basic recursive solution for or recursive traversal of an in-order traversal. And what we want to do is do this iteratively. So what I'm going to do is, in the solution, there's a really good diagram here that I'll kind of use to go through like how to take this and convert it to the iterative approach. So essentially we'll be using a stack here to simulate the internal stack, like when all the function calls go through. So here, so we'll have this stack here, and we'll have our list, which is going to be the answers. And what we want to do is say that while the root is equal, or while the root is not equal to null, or the stack dot is empty. So while the stack is not empty, here we want to go and like visit or go to all of the left subtree nodes. So here we'll say that while the root is not equal to null, we want to push onto the stack the root, and then move the root over to the left. So essentially we'll be putting on 1 onto the stack here, then go to the left, then 2 is onto the stack, then go to the left, 4 is onto the stack, go to the left, and here we'll get to a null node. And so this will break out, so while root is not equal to null, this will break. And then we want to say stack.pop, so that we get back from, we're currently at this null node, we want to come back to 4 now. And we'll say that the root now is going to be equal to stack.pop, which will bring it back to 4. Then we'll go ahead and simulate this part, visiting, which in our case will be just adding the root.value to the output array. And then after that, we just want to go to the root.write. So root is equal to root.write. And that's going to simulate this part, which is going to the right nodes. And then here we want to return answer. And so essentially what's going on is, if we continue this simulation, so going from 4, we'll get to a null spot here. So root is going to be null. We come back here, root is equal to null, and the stack still has stuff, so this condition will keep going. The root is null here, so we won't add anything to the left because there's nothing to the left to add. We'll say that root is going to be equal to stack.pop, which will come back up to 2. And then we add the answer, which is going to be 2. And then we move it over to the right. And then we move over to 5. And now we're saying, once we're at 5, add all of the left nodes, grab the integer value 5, and then go to the right. And then we just keep doing that. Once we get to 1, we do the same thing. We'll be here and say, go to 1.write, which is 3. Go grab all of its left nodes, just like how the recursive solution does. Just get all the left subtree, and then same thing, just visit, and then go to the right subtree. So I hope you guys understood the solution there. Let me know in the comments what you think. Like, subscribe, and I'll see you guys in the next one. See ya.